Hello grade 12s, welcome to my channel, and let us have a look at this piece. So I gave you a bit of an introduction, if you would want to call it that, on differential calculus, and then we started taking some practical questions, or should we say, questions of the nature of the exams you are about to write if you are doing the May-June exams for those students who are upgrading. But this will also help the students in their mid-year exams for those who are the current metric class. So I'm providing this lesson to you guys in a video form so that if you missed something during our discussion, you can have some sort of reference, or for those who could not attend due to some technicalities, they may just see what we did. Otherwise, we are going to use this May-June 2024 paper as our, now should we say, it would be more of an example of how to treat an exam type question during the exam. All right, so of course instructions, guys, very important. So please, you're not bound to start from question 1 until the last, although I prefer that technique. But at times, you just pick your battles as best as you can. Then, of course, we need to be clear as to how we are to structure our solutions. The part that many people essentially miss is this part. And you will understand as we work through these problems today. And issues of rounding off. Again, this says 2 decimal places, meaning no more than 2 decimal places or no less than 2 decimal places. That is it. Okay. And then of course we need to appreciate that these diagrams are not necessarily drawn to scale, but we need to still be able to sift through the diagram to find the relevant information. And of course the diagram has to be representative. So you may have seen a video in my channel where I did this question 1, a very interesting question which I suggest, if you have not seen it, please try it first and then watch the video to see some ideas on how to deal with issues there. Sequences and series, easy stuff as well, but there's plenty of videos in the channel I produced for you guys to have a look at. So the hyperbola, nice and easy. The exponential graph and its inverse, which is the logarithmic, again, nice and easy stuff. The parabola, usually with any other accompanying graph, again, very nice question that can pick your brain a bit, but not too difficult. Financial maths, we're going to look at it at some point before your exams. Today, our focus is differential calculus. So we introduced it. I'm not going to go back to those basics. If you have missed them, watch the video that I recently posted on this topic of differential calculus. And you will appreciate some short notes that I've given you there, guys, so that you can understand exactly the significance or the essence of the topic. Because if that is in check, I can promise you guys, there's not a single question you would not be able to attempt, if not crack. All right, so let's start with question 8 and move along. So for those who were in the class, so this is just more of a fortification, or call it a reinforcement. So we're going to deal with 8.1. Here, the question is for us to find the first derivative from the first principles of this. Not so usual. Most of you have seen a question usually on a parabola. If at all it went to a cube, it would be just one term, which is the highest power, which is the x cubed. Or it could be a binomial, perhaps a difference of cubes, but we never really have something going beyond that, because the whole process would be quite a nightmare, isn't it? Okay. But again, do pay attention. Sometimes examiners do get ideas and they may give you something that may look a bit different, because then this time it does not just test you on how to use the first principles, but it also tests you on how to deal with algebraic expressions of different kinds. Anyway, let's have a look here. We know that when we want the first derivative of any function f, it's going to be equal to the limit as h tends to 0 of this quotient f of x plus h minus f of x, all divided by h. Okay. So this implies that our first derivative is still going to be the limit, so we need to be patient with this statement. Now we do the substitutions into our formula, which we understand now. It defines the gradient at a point and why it does so. So I hope you watched that video and understood it. Okay, so now we have a problem here because this is a fraction, so we probably want to move this a bit further down so that we can allow some space to write this in the function format it is given in. All right, not function but fraction. I wanted to say fraction. So this is going to be 1 over. Now x, we're going to put f. We're going to put x plus h. So this is going to be x plus h. Nice. Minus 1 over x. Okay. Perhaps our situation here is a bit too long for my liking. So this is all over h. Okay. So now we've got a situation that needs us to be more awake in what we're going to do next. So f prime x is equal to the limit. Oops, my m is doing its own things now. My hand sometimes just disconnects from the brain. Now, folks, it is safer to first deal with this like that. So this is going to be x plus h minus 1 over x. This whole left-hand side is divided by, perhaps let's put brackets because students sometimes miss these things. This is h over 1, okay? So this is basically the test by the examiner to see if the student knows these kinds of things, because this is what often will leave you crying if you do not know it. So know your work. Now we find the LCM, which is the lowest common multiple. And how do we get that? When we multiply those terms in the denominators, just as we see them. So this is going to be x into x plus h. Okay, now we're dealing with this situation. We're breaking these brackets, BODMAS, or BOMDAS, or PEMDAS for those who are overseas. Now what we do, we just take this and we literally, you know, some students are very quick. They just cross multiply like this after this. But just knowing that this product of the two denominators must show up there, then we just cross multiply what we have there. So essentially we will have here, what is this color now? We're going to have x minus, it's going to be x plus h. All right, or one can think of it by taking this LCM, we divide by that first denominator, and this will divide this to 1. 1 is invisible, so we remain with x. We then multiply x to the numerator, and that's what we get. We take that the lowest common multiple again, we divide into the next denominator. The x's divide into 1, which is invisible, so we remain with x plus h. We then multiply this into the numerator. So how you want to think about it, it's totally how you are taught. And remember, division can be converted to multiplication when we invert this next fraction. At times there are certain actions you would rather you don't delay too much. Okay, let's just move on nicely. F of x is equal to the limit as h tends to 0. Now we break the bracket using BODMAS. Right, right? And certainly all numerators multiplying and all denominators multiplying. But hey, let's just not rush this. Let's go about it systematically. So we'll have x here minus x minus h, all divided by, we deal with this, it's going to be x squared plus xh times 1 over h. Okay, nice and easy. F prime of x equals the limit as h tends to 0. Now we've got terms that cancel out, so we remain with minus h, all divided by x squared plus xh times 1 over h. Again, we know that those will divide to 1, and 1 is invisible, so we continue that f prime of x here is still the limit. Don't lose faith here. There's a lot of writing this limit as h tends to 0. Now we finally contract this into one single fraction. It's going to be minus 1 over x squared plus xh. Now it's safe to then substitute the h because we will not have 0 in the denominator. So we'll just simply say this implies that our first derivative of f is going to be, now we drop the limit, it's going to be minus 1 divided by x squared plus x into 0, to make it a bit nice. Now we can make our final conclusion that therefore our f prime x is equal to minus 1 over x squared. Nice and easy. Alright, so this is not too difficult, although it looked a bit strange from the beginning. If one understands how to simplify algebraic expressions and the order of operations is clear, please do not lose marks for carelessness. Now, some students understand this. You can already check this answer by checking using the power rule. First of all, our function is not ready for differentiation when the variable with respect to which we are differentiating is on the denominator. So we move it up. It's going to be x to the minus 1. Then we can use the power rule and say the first derivative is going to be minus x into minus 2, because we just take a negative 1 from that exponent. Of course, folks, we often don't appreciate negative exponents in maths, so we just change this to some positive exponent. Same answer as the first principles. As you can see, the first principles is perfect for how we like our final answers in maths. We don't like fraction exponents, we don't like negative exponents. We would rather sit with a radical on the denominator than a fraction exponent. Okay. Otherwise, it's not a big deal if one leaves it here, because when we're using the rules of differentiation, not necessarily the first principles, it is acceptable to leave the answer there. But some mathematicians are very strict. They may push a student into that particular direction. Now, how do we score marks here? So that at least if you're a student, you start to realize how to not lose these marks. First of all, the substitutions must be correct. That is a mark because we can identify the formula that the student is using, provided the formula is correct and provided the substitutions are correct according to a correct formula. Now the simplification here, LCM and what, maybe not. But for me, this simplification is what is key. And then the substitution of 0 there and dropping the limit is a critical step. And the final answer is the target. So this should be 4 marks, literally. But then you start to appreciate the fact that, okay, perhaps this gymnastic here may be given a mark, or any of these other steps in between, because there's a lot that we did. We cannot do so much and not get some marks. Of course, depending on how many marks are being given for that, operation. Very easy after all. So these are easy marks, folks, and you can even check for yourself if the answer you are giving is correct or not. Because if you can find 2 ways or more than 1 way of solving a problem, then it can even highlight some mistakes being committed on perhaps the main question. Now, here we're going to follow on with the rules of differentiation. We're supposed to find the first derivative of each of the 2. One is it's a function, the other one is just an expression. All right, so let's go for it. 8.2.1, we are supposed to differentiate with respect to x. This thing is similar to this dx, like this, the capital letter D, so it's similar usually, so don't ask me what is this. Okay, so we have the square root of 4x to the exponent 6 plus the square root of 2 times x squared. Be careful, the x squared is outside the root. All right, great stuff. So this implies that we're taking the derivative with respect to x of, remember, we cannot differentiate when our variable with respect to which we are differentiating is under the square root sign, and when it is in the denominator. So we convert the square root of 4. Remember, this is a product, so square root of 4 is 2. Then, okay, let's just first split this nicely without rushing, because there's nothing that beats a proper simplification. So this is x to the exponent 6 plus, here we're not going to change anything. It is as we see it. This implies that we're taking the derivative with respect to x. Now we sort this up. This is the same as 2 into x to the exponent 6, all of that to the exponent a half. That's how we remove the radical when it is a square root. Plus, this is the coefficient, we don't need to change it, times x squared. Again, this variable is free of square roots and is not in the denominator. Now we simplify one more. Remember, guys, take time to handle your business. Do not always be in a hurry. So this is 2x. Now we simply multiply the exponents here. It's going to be 6 over 2, which is 3, plus the square root of 2 times x squared. Okay, now we can say this is equal to, remember, this says implies, this is equal to, this is the answer now. In fact, someone may even want to write it on this side, right here, and do the actual differentiation. It's not a big deal, because this looks strange when this equal sign comes down here, it looks very strange. So perhaps you may want to write it this way. Maybe it looks a bit nicer. Doesn't really matter after all. Anyway, so however you want to see this, but I feel it is best this way. Now let's take the derivative here. We're using the power rule. 3 multiplied by the 2 is 6x. We take 1 from there. It's going to be 6x squared. Plus, now we get 2 root 2 times x, essentially. But now this looks a bit unsimplified. One may even go on to say this is 6x squared. Plus, remember, when we bring it back inside, it's going to be 4. 4 times 2 is going to be 8x. Okay, so this is much better. Again, be flexible. Don't be too stiff here. This is mathematics. We perform mathematical gymnastics. We flip and flop as often as we need to, as long as our flipping and flopping is somewhat goal directed. Alright, so what do we do now? Well, this simplification, I suppose we get a mark for this expression simplifying like this, because this one never changed, it was as it is given. So we will get a mark for this, or even we can say the mark for the entire expression. It's not a big deal. The second one is when we do the actual differentiation. That's how we get our 3 marks. Can you see? The marks are not necessarily where we expect them, but yeah. Anyway, examiners can decide where these marks go, but if all the operations are good, there shouldn't be any issues here. So let's do 8.2.2. Now, this one is telling us to find the first derivative. If g of x is that function right there, it's a rational function. Now, the problem is that we are supposed to differentiate with respect to x. Now, x is in the denominator, so it's not ready for differentiation. So we will write g of x is equal to 3x squared minus 4x. No. What is this thing now? 4x to the exponent 4. 3x to the exponent 4, sorry. Minus 4x squared plus 6 divided by x squared. Then we simplify. This implies that g of x is going to be 3x to the exponent 4. Remember that x on the denominator is the common denominator, so it divides each term in the numerator. So that's just the essence of understanding algebraic expressions, inverse operations, because we're reversing what we have been given. This is how we often solve matters in maths. As much as we follow BODMAS, but we try at times to do it as in the reverse. Alright, so the good thing is that this x squared will take the 4 here and leave a 2. And then here, the x squared divides the x squared to 1, and 1 is invisible. Alright, so this still implies that g of x is equal to, now we get 3x squared minus 4. Then we know that this dude right here must go into the numerator, because we cannot differentiate with this in the denominator. So this is going to be plus 6x to the exponent minus 2. Now we are ready to differentiate. We can now start saying, therefore, g prime x is going to be, using the power rule, we get 6x. Now the derivative of a constant is 0, so it's out. So we'll get minus 12x to the minus 3. Now, it's safe to leave it here, okay? It's safe to leave it here. We don't like negative exponents though. Someone else may still write g prime x is equal to 6x minus 12 all divided by x cubed. That's still okay, okay? It's not a must though. There's not so much of a fuss on that issue. Alright, so folks, everything must be done properly, systematically, and to a defined end. We cannot find things hanging. Now essentially, folks, what do we do here? We get a mark for simplifying our function in such a way that we can differentiate. Then when we take the actual differentiation of each of those terms using that rule I showed you guys, of considering those terms of this particular function as two separate functions, because this is more like a composite function of some sort. Okay? Alright, okay. So I hope we understand each other. So we score those 3 marks there. Let's do the last part of this question, which is question 8.3. Sometimes we see it, sometimes we don't. It's not a big deal. Now we are told here that the equation of a tangent to the function f of x equals 3x squared plus bx plus c, which is a parabola or quadratic. At x is equal to 1. Now this is the point of tangency. The x coordinate is 1. Is given by this. Now this is the equation of the tangent. Alright? So what do we learn from that? We know that the graph and its tangent, they share that point of tangency. So we know that the x coordinate is 1. The question is, what will be the y coordinate? The y we will substitute here is going to be 9 into 1 minus 9, which is 0. So therefore the port here is going to be 1 and 0. Meaning it's an x-intercept of this tangent as well as the x-intercept of that parabola. 2, we share more than one thing at the point of tangency. We also share the same gradient because we know that for this polynomial and perhaps a higher order type of, polynomial, because it's in the second order, technically we will then say, fine, its first derivative will give us an expression that helps us to find the gradient at any point on the curve. But now at this particular x coordinate, we will then have the gradient of 9 for the 2. So those are the two things that we need to understand. So it helps, guys, to sit back a bit, read the question with understanding, not in a hurry, not trying to answer, but to get to the point of what the question seeks from the student. Then we start looking at what is the question. Determine the values of B and C. So that's not a big question. It's not too difficult. Now that we understand what needs to happen, we just know that to answer this question, we understand that the f prime at 1 must be equal to 9, isn't it? Now I'm just summarizing, because remember, when you are refined and you know your work, you don't need to write f prime, then do the derivative, then later equate it to, just do it all at once at times. You know what? You will look like a bullet when you are just, a butter knife. Maybe the front part. Now let's do the actual differentiation of our expression. Now we know that we multiply the 2 in front, it becomes 6. Now it's going to be x only, because this is just the second degree. So when we differentiate, it differentiates into the first degree. So it's going to be 3 into 1. Then plus b here, because the x goes. Then c is a constant, so it's not going to feature. So this is going to be 9. So can you see, guys, when you think about it and you plan how you're going to answer, it becomes very easy. Therefore, the conclusion is that b is just 3. Right? Because this is 9 minus 6. So we found the first answer easily by just understanding what we are doing. So we can say here also, we want to find now the value of c. Now the value of c is going to then need us to find the point of tangency. So we can say, however, we understand that at point of tangency, which I would like to call the port. Remember, during the exam, no one knows what port means. Introduce it. That at the point of tangency, the port, it is such that, that is the use of the semicolons. It is, of the colon there. It is such that. What do we know? We understand that technically y is equal to 9 into 1 minus 9, which implies that y is equal to 0. Therefore, we can safely say the port is 1 and 0. Can you see the utility of just being systematic and following things systematically. Because hey, if you become haphazard and careless, everything is not coherent, it's disjointed, we start to lose focus ourselves because we don't know what you're getting to. Even when you make a mistake, we are unable to follow you and help you out at times. All right, okay. So once we have done this, we can safely say then, what do we know? We know that our f of x is equal to 3x squared minus, plus 3x, we found b to be 3, plus c. Then we say with our port that we have found now, I'll try to write better. Sometimes my writing is not on point, so this is 1 and 0. It will be such that 0 is equal to 3 into 1 squared plus 3 into 1 plus c. Therefore c is, now this is 3 plus 3, that's 6. When you transpose it becomes minus 6. Okay, so we have sorted the two variables that we were supposed to sort. Okay, now what do we do? First of all, equating this to 9, whether we wrote it up there, perhaps we may want to mark it there because that's very important. The first derivative at 1 is essentially equal to 9. Now doing the actual derivative here, not necessarily the substitution, is key. All right. Now, okay, maybe that's a bit too much. Maybe what it boils down to is what matters. Then the point of tangency, we needed to discover it so that we can later solve for c. So as you can see, some steps that are usually mark worthy are not really receiving the marks. But this very same question can actually be marked for, say, 5 marks. Because doing the actual differentiation here is certainly mark worthy. So maximum should be 5 marks, but of course the examiners are at liberty to decide how they want the marks distributed. So we are taking these 15 marks with a huge smile on our face if we have not committed any mistakes, because these sort of dudes called mistakes, they like to just creep in every time. You know, when I'm doing these videos, I sometimes laugh at myself because I am trying to say something at the time I am saying it without realizing I'm saying the absolutely wrong thing. It happens. So when recording a video, you just realize, oh my word, how on earth did I come to saying such a ridiculous thing? It's only because you're caught in the moment at that time, so you're not really paying attention to what you are saying because you are so opinionated. The ideas are flying through your mouth and your brain. Now everything just gets mixed up. Sometimes you say the exact opposite without noticing. And of course, when I notice it in the video, I'm like, oh well, the student is going to discover what I was trying to say anyway. If they are awake, they will point out the mistake. If they're not, too bad for them. But I'm not recording again. Sometimes I'm not interested in redoing, especially the long videos. They are really not so nice to redo because of just a small mistake. You will actually go and fix that mistake and then realize you've created yet another mistake on another section. So if you see that the bulk of the video is good, whatever is wrong, someone is going to see for themselves. Right. Anyway, let's move on to some direct applications of differentiation into the cubic function, because it helps us to actually draw the cubic function nicely. Okay, now handling question 9, we read the graph of f of x is equal to ax cubed plus bx plus cx minus 5. But then we're like, okay, what is the value of a? If we look at the shape, this graph is effectively an increasing function, except between the two turning points, right? So from negative infinity, it's increasing. So this shape is suggesting that a is greater than 0. So when we solve for a here, we expect to find a value that is positive. If we find something else, we are doomed. Okay. But b here doesn't really have much of a big role, but I have noticed some things though, that when this term is missing, I have realized that essentially, I don't know if I'm saying the right thing. Now, I think I've said it in one video perhaps, but I've noted that when this term is missing, as in it's not present, so literally what we end up with is one of the... Okay guys, let's leave that for now because I'll start confusing you. Because I must say something that you see. Because sometimes it's not always the case. But I'll review what I was trying to say in case I make a mistake. So the B doesn't really say much, but what we can say here is that technically the -5, the constant is always the y-intercept. So this one is here. The -5 is important, is our y-intercept. So we can easily say from this statement right here, or that particular component of the equation, we can easily say the y-intercept is going to be 0 and -5, because we know that at the y-intercept x is 0. Okay, so that's good. I don't know what I was trying to do there, and it just didn't pan out so well. Okay, nice and easy. So technically the examiner here is giving us the y-intercept, which is an extra point, but not in so many words. We needed to see that for ourselves. Okay, is drawn below, and we are told x is -1 and y is 0. Now we know that whenever the y coordinate of any ordered pair is 0 when we're dealing with functions, that should be an x-intercept. Sometimes I feel this statement is just too much information. If we are trying to examine people, we need to leave them to discover things for themselves, okay? They should not even be labeled for that matter, so that the student actually does the labeling, because this, for me, is just not correct. But again, who am I to say anything? Well, I'm just a joke. That's what I am. So, as a joke as I am, fine, the examiner is very friendly and fair. They decided to highlight this even further, but writing this out like that is already indicative that these are x-intercepts. So the student needs to know. They don't know, then they're not ready to pass maths, right? Can't just pass here. You just can't. You need to progress through this, okay? So anyway, however you look at this, let's just solve the problem. Now, literally we're being given the intercepts, and again, there's a special thing happening at point E. There is equal roots, right? Meaning there's 2 equal roots there. Because whenever the x-intercept becomes the turning point as well, it means there's equal roots there, okay? Nice and easy. So this is another important thing, because a non-suspecting student would be like, what am I going to do now? All right, so let's start answering 9.1. We're supposed to find the values of those variables in the equation. So how are we going to handle this? There are many ways of killing a cat, folks, but the cat just has to die. So if the cat dies, well, it's dead, isn't it? So one can go through the process of simultaneous equations, just saying that at the turning point we have the first derivative equal to 0, differentiate this thing. Of course, the minus 5 falls away. So we end up with whatever equation there is. Then we represent one variable by the two other variables, which is b and c, or a and b, or b and c, whichever we decided to choose. Then we take this very same point, we substitute into this equation, then we get yet another equation. Then we can substitute these symbols wherever we put them. Then we can work out things, you know. We may even need a third equation using another point, of course, on the graph, so that we can get around it. So it depends on really the student's taste when it comes to these things, and in fact on what comes first when seeing this problem. But here's what I know, is that this is the root form of our function. So we know that this is a into x minus the first root. Okay, but the first root, because there's equal roots, it means it's going to be squared into x minus the second root, because we don't really have the third root. Okay, so we say this implies f of x is equal to a, we don't know. This is x, the first root is minus 1, so it's minus 1 is going to be plus 1 squared into x minus 5. Okay, we are good. Now we need a point. We realize that the y-intercept is 0 and 5, sorry, minus 5. So this is such that minus 5 is equal to a. X is now 0, 0, which will imply that minus 5 is equal to, now this is minus 5 times 1, this is just minus 5, a. We can see that our a is 1. Kitchen is done, it's dusted, done and dusted, already. But we just want to sort out this problem once and for all. So we can say then f of x is 1 into x minus 1, sorry, x plus 1 all squared into x minus 5. We then just FOIL this out. F of x is, it's going to be x squared plus 2x plus 1 into x minus 5. Therefore, f of x is equal to, now what I do, I always take this there, I'm going to get x cubed, which spells out the highest power here, which is good because we saw that a is 1, so it's an invisible 1. Now I want the squared terms, so it's going to be this dude times that, and it's going to be this dude times that. That gives me the next term. So the next term is going to be minus 5x squared plus 2x squared, which is going to be minus 3x squared. Okay, so this goes away. And now I got myself into trouble. Goodness. Okay. Nice and easy. And then what are we going to say? The next one is the x terms, right? So it's going to be this dude and that dude, and then this dude and that dude doing it for me. So this is going to be minus 10x plus x, which is going to be minus 9x. Okay, so again, get rid of this. All right, great. Now the last one is just the constants. So this is minus 5. Are we not where we're supposed to go? We are just there. So we know that a is 1, b is minus 3, and c is minus 9. Answer. So this one is a bit easier than the simultaneous equation route because it may force us into even a third equation, but we have enough information anyway to go that route, so it's not a big deal. So how do we score marks here? This writing is good. right? Right. And then working out A here is good. And of course, realizing that this point, so this is, wow, 3 marks. Hi guys, man, Helek, what is that? Heaven. So basically, the marks are now here and here, but this should have been 4 marks at least. But it looks like the examiners are like, no, we don't care about how you get the answers. It's all about those answers at the end of the day. Okay, let's leave it at that. 9.2. We need to calculate the value of x for which x has a local minimum value. Now we know that the local minimum, remember, once we say maximum when curves are involved, we say a maximum is always concave down, right? And a minimum is always concave up. So this is the point we're talking about, is that this is what passes through there. Not so nice. Okay, this is what passes through that point. So the examiner is asking a very important question as to what is the x-coordinate there. But now we know that the x-coordinate at the turning point comes from the first derivative also being equal to 0, because we know that a tangent drawn at the turning point has a 0 gradient. Why? It's a horizontal line. So we're going to use that concept of differentiation. So we know that f prime x is 0. Maybe let's just say at a minimum, it is such that f prime of x is equal to 0. Very important. This implies, now we differentiate our expression, we get 3x squared minus 6x minus 9 equal to 0. And then 3 is a common factor, so we get x squared minus 2x minus 3 equal to 0. We can factorize the business here. So this is x minus 3 plus 1. But now where is this one? So we can say therefore x at a minimum is going to be equal to 3. Why am I ignoring the minus 1? Because that is the maximum. And the question said at the minimum value of the function. Okay, so this is good. Not a very complicated story. Again, we are scoring a lot more marks here, strangely, and yet not so much work needed to be done. How ridiculous. This is, I feel the extra mark here belongs above, and then the 3 marks actually belong here. But what matters here is equating the first derivative to 0 and doing the actual differentiation and the final answer. There's no 4 marks here. But we know that whenever we factorize, because it's part of the 3-step approach, we essentially score an extra mark. But I feel this mark belongs above. So poor structuring of questions here, essentially. 3 marks. Remember, factorization is a means to an end at this point. It's not really being tested per se. Anyway, we move on. We don't want to hold on too much. Okay, let's have a look at the next question. It says use the graph. Now, when this statement comes, folks, you cannot use other means that you know. Here, it is very clear that you are to use the graph. And these are some of the higher grade questions because they're not too obvious. So we need to use the graph. We can't use the second derivative, for example, when we are looking for this expression. We cannot use differentiation because that is the discouraged part. So these exams, guys, are very technical. Trust me. You may overlook these things because you're going to get the same answers, but the problem is that you have not followed an instruction. And if you're not following an instruction, you are going to lose marks. It will depend on how fair the examiner is, because if you don't use the graph when told to do so, for me, you get 0, even though you got the right answer, because you don't deserve that answer. You are cheating. As much as this is the correct way to solve, but it's called cheating when you are literally not following instruction, because it means when you decided you're going to do what would obviously work. But now what if the examiner is checking something in you instead? And now you're not giving that thing that they're checking for. Then how can they say safely that you know what they were looking for? They can't. So please try to realize that here you play to the instructions of the examiner, not your own knowledge too much, of course. But where there are areas like determine this and no one states how to determine that, that's an open-ended question. So you can do whatever you know. But when somebody says calculate, you cannot come with statements and deductions here. If the question says calculate, we must see a calculation. Whatever motivates that calculation, we don't care, as long as we see a calculation, okay? So be very careful at times when a question is specific and you do your own things. But when the question is open-ended, you know what to do. And I have been highlighting this throughout my videos. I just do hope I've been consistent, because sometimes I say crazy things that I myself don't understand how I came about saying them, because I cannot believe myself at that time. But doing these videos highlighted something. I used to be worried when people don't seem to get what I was saying. And then I'd be like, but these people are slow, man. But now when I watched myself on these videos and realized how so many wrong things I say without noticing, then I started to appreciate the fact that, oh, no wonder these folks would be so confused. Sometimes I think I'm saying what I'm saying, but because of the heat of the moment, I actually say the exact opposite at times. Anyway, let's leave the stories for now. They're good for later. Now it says we need to determine the values of what? X. For which f double prime x, meaning the second derivative of x. But now this means y values of the second derivative function. Y values multiplied by the y values of f. Okay, y values. So we're multiplying the y values of the second derivative function to the y values of the original function, and we are saying this product must be greater than 0. So now this question needs a proper analysis here. So there's a specific reason why the examiner is saying we need to use the graph here, because we could easily do something else. I could personally solve this algebraically, because I can, you know, I honestly can, because remember, we can factorize the f of x into this nicely. And guess what? The second derivative function is a straight line, so it's also a binomial in a way. So we could actually solve the inequality using, you know, the table method, for example. But now this is being discouraged. So we cannot see that. If we see it, score 0. I'm sorry, guys. Anyway, so what is important here? We need to find the point of inflection. But now we just need the x-coordinate at the point of inflection. And this should be between these two. So if there's 3 here, let's have a look. So this is, oh, by the way, we saw that this is 3. The x value here was 3. We discovered it is 3. Now we know that the point of inflection is an average between the two x values at the turning point. So 3 minus 1 is 2 divided by 2, that's 1. So this means our point of inflection is somewhat here. Okay, so we can see that this is 1. So this would be the point of inflection where the x-coordinate is 1, which is the average between the x values of the two turning points. That's the essence of saying use the graph to determine this. So now we know that to answer 9.3, we need to be very technical. We can safely say x at the point of inflection, x at point inflection. Sometimes you can say this is boy. Remember, try to say something so that we can understand when you finally use the abbreviation, because this can simply mean a point of intersection. So we need to know, because some conflicting abbreviations are dangerous. This is why our former teachers hated students who use abbreviations, because they create confusions. Sometimes they are controversial. But if you are going to introduce it and then be consistent in its use, then you will not be misread or misunderstood. What do we know, guys? We know that x is equal to this 3 plus into minus 1. We just show that this is an average, which means x is going to be equal to 1. All right. That's what we need. So after we have done this, what do we know? We can, for ourselves, and decide that, look, if a is greater than 0, we understand perfectly that the graph of the second derivative is going to have its x-intercept here. We're not going to necessarily draw a sketch that is, to scale. But all we know is that the second derivative function is going to do stuff like this. Okay? At this very moment, we don't care where it cuts specifically in terms of the y-intercept. All we care about is where it cuts on the x-axis. It cuts at the average x value between the two turning points. Nice and easy. All right. So now we can start analyzing. Remember, whenever we read a graph, we read it from left to right. Please don't read it in reverse. This is not how it works, okay? Otherwise, we'll get into trouble. Now we can section our graph into 3 regions, maybe if we want, but let's just go about it systematically. Now, if we come from negative infinity, we'll see that this graph, the y value here is negative all the way until we get to the turning point where the y value is 0. Okay, and then it still remains negative up until we get to the y value here, which is now not 0. Whatever the y value it is here, it's negative, but it's still negative here at the turning point. Remember, the black now represents the signs. We may even rub off this part because we've used it and we have exhausted its utility, at least for now. So I can safely say at this turning point, my y value is not 0, but negative. And it's still negative here. Then it's 0 at the x-intercept. And then it becomes positive. So we have mapped out the signs of the y values on this function from left to right. Now let's look at this second derivative function, because this is f double prime. Now we look at it. Below the x-axis, the second derivative function is negative. Above the x-axis, the second derivative function is positive. At the x-intercept, it is 0. Now, the question said greater than 0. So it means the 0 marks for each graph becomes an important area to look at. Now, let's divide our function into sections so that we can study what is going on. All right, guys, so we have divided because we knew that 0 becomes a critical value here, because any product, when one of the factors is 0, the entire thing becomes 0. So in a product, when one factor is 0, the rest of the thing becomes 0. So these are the skills, guys, that you need to really master. So now we can see that from negative infinity up until when x is minus 1. because the y value is 0 there. We will see that this is a negative multiplied by negative, which is positive, because from grade 8, minus times minus is equal to a plus, and a plus is essentially greater than 0. Great. So we will see that this happens up until we get to 1. But at 1, we know the y value of the other function is 0. Therefore, the product becomes totally 0, and that is excluded. Okay? So we can safely write here that therefore x must be less than minus 1, because we can see that below minus 1, the product holds true for the inequality that we are given. And this is from negative infinity. Remember, negative infinity may never be included. Okay, I don't know why my infinity is starting to look crazy now. Yes, there it is. So we can write it like that. It's good, but we need to indicate that this is minus infinity. Okay, so this is that section right here. This is the good section with the exclusion of minus 1. And then we come in between here, minus 1 and 1. Guess what? The two functions are still both negative, so the product is positive. Or x must be less than 1, greater than minus 1, because remember we saw that minus 1 is not included. And also 1 is excluded here, because if we say 1 is included here, then the y value for the second derivative function is 0. So that product becomes equal to 0, which is not included. Alright, or then we follow on to the next interval. So this interval here is good. And we follow here and say from 0 to minus 5, this wide interval. What is going on here? You can see the second derivative function is positive, whereas the original function is negative. So that product is less than 0, because we know that positive multiplied by negative is negative, and negative is less than 0. So that's why this interval is not acceptable. Then greater than this value, because we can also not take 0, but greater than this interval here, we can see that this is positive and the second derivative is positive. So that product is going to be essentially positive. So we can say x must be greater than 5. Nice and easy. In fact, this portion here can be written like this. We can say here x must be less than 1, greater than minus infinity. Don't know why my infinity is doing things now. Provided x is not equal to minus 1. Alright? Or then we do this, x must be greater than 5. So this answer can still be written like this. But if we do that, we need to take care to exclude x as minus 1, because here it ends up being captured within that interval. Then we can get our marks here. So how do we score marks? Anyway, of course, this is a mark, this is a mark, and that is a mark. So that's how I think the 3 marks are scored, provided this x value is shown using the graph. If not, then one of the marks gets lost. If one chose this technique, it's still simple. You get a mark for this, for the restriction, and we get a mark for that final answer. So 3 marks will get scored no matter what we choose to use. Great stuff. So let's do 9.4. 9.4. Again, it's another higher grade question, because this one involves a lot of thinking and understanding how things work. So essentially, that's the story. Now let's have a look. We are asked a question as to for which values of t this time. Remember, t is a variable, so it is a constant. Remember, once we use a variable like that, this is a constant. Yes, it may take any value in general, but in this particular function, once we have conditions, it has a specific value that we need to look for, or at least a specific set of values that we can consider. Okay, now for which values of t? Well, the graph of p of x, can you see it's a different function, but it becomes a transformed function of f, because now this is f plus t. Okay, let's remove these y values because they're interfering with the work here. So we can see that f of x plus t, t serves the function of a vertical translation. Some people like the word shift. So it becomes a vertical translation of f, basically. Now this one may be up, may be down. We don't know which one. So which one goes to the things? Now let's start playing our tricks nicely, because we are the nice ones. We know how to do our things. Now let's see, what can we do? So let's just map this graph nicely. Of course, it's going to be a bit bad, but I am a surgeon, so precision is key. Whether you have excuses or not, it's not too bad. Anyway, so what I want to do is to steal my function so that I can play with it. Of course, you don't have this luxury in the exam, so you may have to do a dotted transformation of the graph above on certain regions, which I will show you next. Now we can move this graph down, but if we move the graph down, even if it's just 1 unit down, what you will notice is that we lose that x-intercept at E. So we only end up with just one single intercept. But remember, the condition is that this must have two distinct positive, meaning they must be of different values, but they should be positive roots, and one negative root. So we lose the negative root and we end up with just one positive root here when we move the graph down. So it means we cannot move this graph down. So in essence, this is suggesting that, okay, hold on, our graph basically is moving upwards, because if we cannot move it down, it means it has to move upward. So this is a vertical shift upward. And now if this is the case, it's moving upward, it means t must be greater than 0, right? Why do I know this? Because I already have a positive here. So it only makes sense that if this graph is to move upward, the sign of t, when I already have a plus between the two, it means the sign of t must be positive. So meaning t must be greater than 0. So just by understanding what is going on, after understanding what is going on, just understanding the dynamics that need to be followed, you start to see a clear picture of what is needed from you. So guess what? The values of t, it means t must be greater than 0. Already we have one portion of the inequality. Is that all? Should t be just positive all the way to positive infinity? Or are there any limits? So always think of limits with these kinds of questions, because sometimes it may be easy. I mean, it may be easy to find the first part, but the question is, are there any limits to how this t should be? Now let's have a look again. Let's move our graph up. As you can see, when we move this graph up, what do we see, guys? You will see that this is the origin, and can you see the x-intercept here is positive, the x-intercept here is positive. So we've got two distinct positive roots and a single negative root. So this is satisfactory. Keep moving. Say, okay, however many units this is going on, and as we can see again, we still have a positive root and a positive root, and these two are distinct, meaning they're different. Then we still have one single negative root, and we keep moving, and we're like, okay, how about we move it up until the turning point is just sitting on the x-axis. Now what do we see now? This becomes two equal positive roots instead of distinct. Now this defeats the purpose of the distinct portion. So it means that's the limit. Let's see, could we be crazier and move further? Of course, this one, when we trace it down, is going to give us one negative root, but then we lose the positive roots altogether. So that is not good. So this means this is our limit. It means our graph can move upward up until it reaches the x-axis, and it cannot move down. So that's the limit. So now the limit is already suggesting, my dear friends, because if we take our graph, for example, and say we're going to copy it and then paste it, just so that we can demonstrate what we're doing here. Let's put it where it's supposed to be now. This is the region where we expect this graph to be, right? To satisfy the given constraints. Now this is the correct position, the middle one. Let me highlight it. This is the portion that is correct, because we'll see those two distinct roots. But now we need to move it upward less than this total distance. Okay, let me highlight it differently so that we can appreciate what we're doing here. So we basically are suggesting that we don't want to move our graph more than the value of this vertical distance. Yes, it has to be a vertical distance, positive in that we're moving it upwards, so it should be greater than 0, but it must not be equal to this length, because when it is equal to this length, it means we're going to move this turning point right up into the x-axis, and then we end up with two equal positive roots, and we want them to be distinct. So the question is, what is this length right here? This length actually is read by the corresponding y-coordinate on the function. So the good thing is we already know the x-coordinate. It's 3. So just substitute the 3 back into the original function. It gives us the corresponding y-coordinate. Now the corresponding y-coordinate is just going to be, because remember this is from 0 to there, so it's going to be exactly the amount of units we need. So we start by saying f of 3 is equal to, what did we get above here? F is x cubed minus 3x squared. So x is 3 cubed minus 3 into 3 squared minus 9 into 3 minus 5, right? Yes. So this implies that, or maybe we can even conclude here and say, therefore, f of 3 is equal to, remember this is 27, this is 9 by 3, that's 27, this becomes 0. And then here we've got minus 27 minus 5, this becomes minus 32. Now this minus 32, remember, as a length from the origin down is just 32 units. So we just ignore this in our answer, but we just show this, that this is what we are looking for. So from here we can safely write, because nobody said how must we explain this, however we choose to explain it, as long as we get to the answer. We can say here, therefore, t must be less than 32 but greater than 0, because we saw that we got this piece by just understanding that we're moving this upward. Since there was already a positive sign here, then t automatically needs to be positive. If, although p of x was written as f of x minus t, and still the same conditions given, because of this negative, it would mean t must also be less than 0, because negative and negative would then give us a positive, which would be ultimately the shift upward. So sometimes how things are given is how you respond to them. Again, this is just an example of a variation of how this could be given in the next exam rather than the way we are seeing it, so that you don't start crying and be like, what is this now? Remember, t can take any value as long as we correct for the given expression. Now, this is good, guys, because you wouldn't know these things if you didn't understand how these graphs shift. Now, what matters here? First of all, we get 2 marks for the we get 2 marks for those values, the 0 and the 32, because we needed to come up with them and the inequalities. And of course, establishing our f of 3, that it is the exact distance that we need. Although it doesn't really come out nicely, but we know that in terms of distance, because t can take any value or sign. Now this time we're choosing the positive one, and we're saying we can't move it by more than this distance, because we saw that when we do that, we lose this x-intercept. And when we just give it that same length, we actually end up with 2 equal rows, which is not what we want. But less than that and more than 0, we see that our graph falls right where we need it to fall, and it gives us exactly the quality of the roots that are being asked. So this is how, guys, a question of this nature is answered. Otherwise, we would be taking away some very, maybe not so easy at the end. Maybe the last 2 questions are usually not so obvious. Sometimes they create a bit of a nightmare for students. But guys, I've done a lot of these videos, past exam question papers, where I take the paper from the beginning to the end, which I am not interested in doing anymore because it's a waste of my time. And certainly many of you don't respond so well to that anyway. So if I'm giving you what you don't need and I'm wasting my time, I'm literally goofing around. So this time I'm going to avoid doing full papers unless you have a specific request, which I can accommodate when I can, but I'm no longer interested in doing that, because remember, I've created a nice baseline for you guys to have. Then I can just chop on specific topics and sections and questions now, because you already have a full video from start to finish of questions. You can see how you can maintain your focus, and you will see how mistakes creep in when the tiredness sets in as well. So you can start to make up for those issues along the way, or also to build your stamina. That's why I made those long videos earlier on, so that all my students, when they start out, they become a bit more endurance driven. Then we can start focusing on specific technicalities so that you become as good as any seasoned technician, because maths needs you to be a technician, my friends. You can't just be a commoner. You need to be a skilled individual. Talent alone is not good enough. Talent can only make you be noticeable, but it is not going to certainly help you survive or sustain you. But if you combine talent with skills, you become unstoppable. And skills, unfortunately, you learn by observation, whether you like it or not. No matter what type of student you claim to be, but if you have not observed anything, you will hardly learn anything, because you don't even realize certain things that you learn by yourself until you see someone else reciprocate, or at least shows you what you already know. And then you're like, oh my God, I was aware of this for like as long as I lived. But you never thought it is that significant until somebody shows you that it is indeed significant. Guess what? Some form of confirmation is part of our nature, unfortunately. As much as we go around talking nonsense that, yeah, I'm not going to be defined by anybody's what. You are lying to yourself, guys. This is just psychological bullshit that sometimes I just, Anyway, let's not go to how I take to this psychological, what you call ego stroking bullshit. I'm sorry for the language, folks. Sometimes, a little bit of harshness there is quite very useful in sending the right message, because trying to find a nicer word makes people miss the point. But if you say some very harsh words, at times they start to remember the words and then realize the intensity of, the rejection of certain things. Otherwise, they don't really get it. Remember, certain things have to be intensified for people to appreciate. But if you give them in the right measure, they don't appreciate the significance of, the whole message. So essentially, folks, that's just the thing. That's just the thing, or that's just how it is. Go cry in a corner somewhere, then come back and learn some maths. Okay, guys, let's get to this application. I've done this question before, so I'm just gonna cut through the chase here. I'm not cut through the chase, but I'm gonna cut to the chase. I'm not gonna waste my time. Of course, guys, I highlighted that this question can be answered algebraically, but okay, this one might be not so friendly algebraically. Okay, please don't do it. The cubic function, unfortunately, for questions of this nature, when there's a transformation, algebraically they are horrendous. They are horrific. They are catastrophic. They are ruthless. Maybe you need some higher order, concepts and thinking that is probably beyond the scope of metric level in our country to then navigate this algebraically. Yes, it can be navigated. There's lots of there's some sets of rules, that can be applied here to go around the corners here. But unfortunately, if you start showing up with, concepts that are ahead of your syllabus, unfortunately, then the chances are that no one will believe you did this by yourself, and it means you copied. And unfortunately, as bright as you may be, maybe you did your homework and went the extra mile, but you may find yourself not being believed, because what are the chances that you would study things of that nature when already you have too much on your plate? It's ridiculous, is it not? Anyway, guys, let's stop the nonsense and just keep moving. Let us keep moving, Mos. Yeah. We need to keep moving like that, like this, like that, like this, like that. Anyway, anyhow, I was just thinking now, what other method would be good to do this, folks? I'm trying to figure it out now in terms of what method could this be, or what should we do to do this. Unfortunately, yeah, the way it's written, I think it forces us this path of vertical shifts and stuff, because yeah, it's a bit naughty now. If this was a parabola, we could do it algebraically, but not a parabola. I also don't know much. Anyway, guys, I don't know why I'm so obsessed with this question now all of a sudden, but yeah. Let's get to question 10. I think that's fair. Can I answer question 10 right here? Maybe let's try. I hope it doesn't disappoint, but we can easily copy the whole thing through. Alright, question 10. Given information that EHGF in that order is a rectangle. Oh my lord. What is a rectangle? All the four corners are right angles. Number one. Numera una. That's the stories. 2. If these co-interior angles add up to 180, as we can see, then it means these damn lines are parallel. But now if this is a rectangle, they are not just parallel, but they are equal. Oh Lord. Then the other pair as well, because those co-interior angles are going to be supplementary. So this one and that one are parallel. They're not just parallel, they're equal to. That's the properties of a rectangle. Lord have mercy on me and you. If you don't know Euclidean geometry because you thought this is paper 1, too bad for you. Maths, let me just warn you guys, when it comes to application sections of certain concepts, just expect even a concept or an issue of paper 2 showing up in paper 1. Every time you get to applications of certain ideas, expect anything from trigonometry, Euclidean geometry, analytical geometry, because it will come to haunt you. Even when you go to paper 2, when you get to areas of applications, of optimizations and stuff, calculus, differential calculus will come in. Okay? When you're handling functions, you're going to still treat that as some sort of a function. You know, the transformations of points on the Cartesian plane in analytical geometry, for example, they still bring up this whole thing of transformation of, you know, functions, whether it's a reflection or it's a translation, you name it, okay? So just be aware that at these points, most of the time, not always, most of the time, applications of concepts of yet another paper, when it comes to paper 1 and paper 2, issues from each paper can be brought early. So don't think because you're not doing paper 2, you're not going to study paper 2. Yeah, you have to, guys. You have to understand everything before you write. So you can't just study for paper 1 only. Yes, most of the work, say 2 days before the exam, you need to concentrate on paper 1 concepts and make sure they are clear. Then that day before the exam, because you will have not much to do now, and so that you avoid overdoing things, start looking at paper 2 and start trying some basic concepts and make sure they are clear and brushed as well, because guess what? The next paper is going to be paper 2 anyway. All right, let's move on. HE produced, meaning it's the same straight line, x squared centimeters, hear that? That's a length. 2n, so HE, where is this? HE produced to n x, so there's this x centimeters, so it's already indicated. And EH produced x squared centimeters to p, again the same story, there it is. All right, we see it's indicated, we don't need to do it. Now NF produced intersects PG produced at M. So they're trying to create a triangle here, which forms an isosceles triangle. Here, this part, isosceles triangle MNP. Okay, with NM, this whole length equal to MP, the whole length of the side. Okay. Right. Now remember, any isosceles triangle, so here's the key right here. Isosceles triangle, right? When it is sitting on its base, and the perpendicular height to the base will always bisect the base. Yeah, this one is those kinds of issues that are very, very, very technical indeed. So basically, we know that this becomes the perpendicular bisector of NP, such that ND is going to be half of the entire length. Remember, the entire length is 4, so this is going to be 2. And the same will apply here. It's going to be 2. You see, guys, if you don't study for knowledge, your questions of this nature will always embarrass you. But hey, everybody will get what they deserve, isn't it? If you are one of the people who are just going through the motions, or are complacent in nature, and they expect miracles, you will always suffer. But if a miracle finds you doing your part, it will always give you an edge above everybody else. Anyway, whatever you choose, it's up to you. Technically, we are told now that D lies on NP where MD is perpendicular to NP, and so we already went ahead of the statement right here. Now NP is 4 centimeters and MD is 3. So now MD is this entire length right here. Maybe let's highlight it like so. Okay, it's just telling me that this is not necessarily a straight line, so I'm just going to highlight it and leave it. So there it is, and we are told this is at right angles to this one. So this is 3 centimeter. Anyway, anyhow, we are done with the analyzing of our sketch and understanding concepts of Euclid. As you can see, this is heavily Euclidean geometry, even from lower grades than metric, because this isosceles altitude on the base is a perpendicular bisect, isn't it? If you didn't know it, now you do. If you did know it, then you remembered it again. First and foremost, we are to show the area of EFGH, which is our rectangle that we were introduced to. See how they changed the story so that it looks as if it's different. We were told this is EHGF, now it's EFGH. In case you miss it, you are dead. It's given by the area A of x is equal to 6x squared minus 3x to the exponent 4. Okay, we are happy with this one. Now what do we say here? It's clear now that we need to represent the sides. We need to represent this side, EH, in terms of x. Now this is good because the entire length is 4. When we take away those x squareds, guess what? We'll get EH. So we know that EH is going to be 4 minus 2x squared. Nice and easy. So this is you and I now trying to map out a way. Okay, this one is easy to do. But now there's a B that nobody told us anything about. Now we're like, what the hell? Yeah, man, what is this thing now? This thing is doing its own things. You see, there's a B that was not mentioned here. So this B is essentially EF or FE. And if that is B, this also means this side should also be B, which is GH or HG. Now, essentially, this whole thing is in terms of X only. So this means we need to represent B in terms of X. That's our task. So how are we going to do this? Well, we need to think now. Remember, we noticed that these were parallel, nice and easy. But technically, if this is 90 degrees, again, co-interior angles come into the 4 as well. So this means this is also parallel, like that. So guess what? We end up with some kind of a triangle where proportionality theorem comes in. Okay? So now let's have a look. What can we do? We can clearly see that we need this triangle MND, right? So essentially, guys, we've got this shaded triangle MND or DNM or DMN, okay? So we can see that EF is literally drawn parallel to MD or DM, and essentially we can use our proportionality theorem here. Okay, nice and easy, because we can see that ND is 2. So now this means ED, if we need ED, it's going to be essentially 2 minus x squared if we need to do that. But let's see what we can do. So to answer 10.1, now remember, guys, working on the diagram helps a lot for someone to understand some of the things you say, because this is not necessarily a Euclidean geometry section, of course, so we cannot be too fussy about it. But remember what the instructions say, etc. So whatever we say, we need to justify. But at the same time, if we look at the marks allocated, it tells us that some things we may have to skip over. Okay, but now what I want to say, guys, is to say in triangle MND or DNM or DMN, whatever we want to say. Now what we're going to say here is that, first of all, in this triangle, in this particular triangle, we understand that we want to use the proportionality theorem, but we are going to be very strategic on how we're going to do these things. So we're interested on this side EF in terms of X. So this will work with this. So this would mean that short segment NE has to work with the entire ND. More like looking at the two similar triangles, this small one, NFE, and NDM, or whatever. Okay. So I will just simply say here NE over, or yeah, NE over ND must be equal to essentially EF over DM. Okay, now this is from the proportionality theorem, right? Now we need to state the parallel sides. We can say EF is parallel to DM. Well, since we need to provide a bit more here because we didn't speak about anything, since essentially EF is, how do I explain this now? We can say since, let's just say since F E, what was it called? EFGH, since EFGH is a rectangle. All right, and DM is perpendicular to NP. Okay, so this is a bit of a comprehensive reasoning, because at the same time, guys, when you're writing the exams, you don't want to find yourself saying too much because you don't have the time. Usually students make a mistake of coming for these questions last, and that's bad. In my opinion, start with these calculus things so that they understand that even in the function section, calculus still applies. I mean, differential calculus still applies. So this helps a lot to keep your brain sharp, you know. You start with these questions that are going to be a bit demanding. Things that include applications are always on the demanding side of things. As you can see here, we needed to furnish a reason and why these two sides are parallel, because we know that with a rectangle, that side is going to be parallel to the other one, and the orientation of MD being given perpendicular, it will literally be parallel. So this captures all of these things. Don't take these things for granted, because you are learning to summarize mathematics. Some people even tell you clearly that math is a language, guys. It's a special language, not just a common language. It's a special language, so you cannot have slang here. You need to say things properly. So NE is already given. It's x squared divided by ND. We said it's going to be 2. Now we need to justify where this 2 comes from. This is equal to EF is B as given. DM was 3 again as given. But we may want to furnish a reason for why we chose ND to be 2. So why is that? So now we're going to say something as well. We can say DM is a perpendicular bisector. So we can say DM is a perpendicular bisector of NP such that ND is equal to DP in isosceles triangle. So please, guys, try to be as comprehensive as possible so that you're not misunderstood. In isosceles triangle MNP. Can you see the altitude only bisects the base or the basal side of an isosceles triangle, not any other triangle. So this is why we need to try and be sure that since we were given that this side is equal to this side, it already tells us this is an isosceles triangle. And therefore the altitude to the base will definitely bisect the base into two parts. So we are literally suggesting why this is equal to 2. Of course, someone who doesn't know what I'm trying to get to will be like wondering what the hell. Because I mean, this 2 was not given, so it should be clear that this is only explaining the not given part. Because x squared was given, b was given, 3 was given. So why would this justification be there? It definitely explains the 2. So there are certain things that are implied, not necessarily clearly stated. Okay, now we cross multiply to solve for b. So we literally going to have our b here as 3 over 2 x squared. Now we have succeeded in showing our b in terms of x squared. And remember, our reasons are the etc. part of our instructions. Do not take that for granted. Now we're going to go on and say then area of x is going to be length times breadth. But now the length here, I'm not going to write the formula in terms of the generic stuff. Now I'm going to write it in terms of this rectangle. It's going to be EH multiplied by EF. Okay, nice and easy. So, which will imply that our area in terms of x is EH. Since we are lazy now to showcase everything, we can clearly see that logically, or whatever means necessary, it's too obvious here that this is going to be 4 minus 2x squared. We don't need to explain this. EF is that b, which is 3 over 2x squared. Now just FOIL this thing out. A of x is equal to, we multiply this to the first one. 4 divides 2 into 2 on the numerator. 2 times 3 is going to be 6x squared. Minus, we multiply there, the 2's divide to 1, we end up with just minus 3x to the exponent 4. Very easy once you know what to do. Okay, of course, if you want to know how I went about it in the first video, because at times you just want to show students how they would struggle through a problem at first, because you will not have the summary at first. This is the essence of using an extra page to do some rough work. Once you are satisfied with your steps, then you try to summarize without losing the essence of what you're doing, because everything needs justification when it is not clearly given. As you can see, I justified everything I'm doing because I don't want to go through the craziest of motions. At the same time, annotating the diagram that is provided in the answer sheet also assists in saying some things that you are saying. That can also help, because this diagram is complicated in a way, so you may fail to really justify yourself properly there. So anyway, we solved the problem. So what do we say? The statement and its reason is key, folks. And solving here is also key, provided there's a reason that explains certain things, because this too needs to be justified. It cannot just come up. Of course, what else is there, folks? Using our area formula for a rectangle, or you can call it substitutions or whatever, that should be good enough. Okay, in fact, here it's not really the substitutions that matter, but I think the calculation of EH is what perhaps is more important. Now, again, the marks can be distributed however one wants, because there could be a general feeling that this justification is key. So instead of giving too many marks for that, we can even give a mark here and say, well, the part that gets a mark is the reason for that too. in the end, it depends on how the marking guidelines are structured, and it is at the discretion of the examiner and the quality assurer. Calculate the maximum area of the rectangle. So this is easy, most. We know that a of x is equal to 6x squared minus 3x to the exponent 4. So we can say for maximum area, it is such that a prime x is equal to 0, which implies that 12x minus 12x cubed is going to be equal to 0, right? Right. Now, we know that the highest common factor here is 12x into essentially 1 minus x squared is equal to 0. So we are good here. So again, we've got a difference of 2 squares here, which we can factorize the way we know how. This is 1 minus x and 1 plus x. Okay, so therefore x here is 0, or x is equal to minus 1, or x is equal to 1. Okay, it doesn't really matter. Maybe the order, since now this is going to give me 1, this is going to give me minus 1, so maybe I can just change for the sake of consistency in the way I wrote my factors. It's not a big deal otherwise. Now folks, we go back and say, hold on, what is possible here? Of course, if x is 0, it means there's no area. The area is 0. So we can't have a 0 area and this is a maximum. I mean, nothingness doesn't make any sense. So x cannot be equal to 0 without any doubt. Not necessarily to say this equation didn't solve into 0. It did. It's a cubic function. We're going to have 3, roots here. But this root is irrelevant in terms of what we're trying to get, because now this is a practical application of area. Can't say a 0 is a maximum area. How can it be maximum? 0 is the minimum, isn't it? It's always a minimum, because the area is either negative, it's either 0 or it's some other positive value, but it can't carry a negative value. So again, this is where critical thinking comes in. Okay, now the issue is, could it be 1? Could it be minus 1? Now we look at the expressions, we can see that the exponents are all even. Now even exponents, they can take a negative, they can take a positive, right? Meaning we will get the same answer there, because there will be no different answer whether we use minus 1 or plus 1, since the value is the same except the signs. With even exponents, for the variables where we will substitute those values, it does not matter. It always gives a positive answer. So we will have the same answer. But now, be very careful. Do not find yourself substituting this value. The reason is x is centimeters. So we can never have a negative length. Okay? That again gets out of the business, although it qualifies on the expression like literally, but in terms of what this represents, it does not feature. So if you substitute this, you lose marks. Okay, so this is the x that we need. Okay, so we can even make a nice conclusion that x must be essentially equal to 1 centimeter, because that's the unit here. You need to be very clear about it. We can say here then, we can say the maximum area is such that a of 1 is going to be equal to 6 into 1 squared minus 3 into 1 to the exponent 4, which therefore tells us that a of 1 is equal to, this is 6 minus 3, which is just 3 centimeters squared. Done and dusted. Alright guys, easy stuff otherwise, but you can see that a lot of thought and planning and even getting to the answers, you can't just choose whatever comes to your mind. You have to analyze if this thing makes sense in terms of the implication this time, rather than just the pure algebra in front of you. Alright. We see, so equating the first derivative to 0 is a mark. Actually, doing the actual differentiation is a mark. And finding the x value with the correct unit is a mark. And the final answer again with the correct unit, that's the mark. So that's how we find those 4 marks. And of course guys, you can tell this was a rather painful 8 marks. And many students who wrote this paper got nothing here. Okay, let's not say they got nothing, because some smart ones, they will just ignore. They would lose the first 4 marks, but they will definitely capture the last 4 marks. Because once you have this expression, all you have to do is to differentiate it and solve. So there's no need to not score these 4 marks. So most students would get that. But the first one, they may really choke. Because it's a hot potato. It is going to cause you problems. Anyway guys, I hope you enjoyed the video. Tried my best to be as clear as possible. Of course, it takes a moment to solve these problems. As you can see, I was trying to explain, so I ended up doing it for more than the time you should be doing these kinds of questions. For you guys, maximum is 45 minutes doing the entire calculus, or should we say differential calculus segment. Maximum 45 minutes. In fact, try to take it under 30 minutes if you can, because I can tell you guys, when you're prepared and you're ready, none of these questions are that much of a challenge. It's just those 2 or 3 that will force you to think. Even there, you will not struggle to find a way, okay? Otherwise, the first part is just the pap and place of this section. You just get marks there. There's nothing to lose. There's just nothing to drop here. Take the marks. Question 9 always has some thought for the student, especially those higher grade questions. The rest is standard textbook material. This one is definitely not so obvious, the 10.1. But the 10.2 again is the pap and place in the textbook, study guides, whatever. So guys, you can see that here there's 3 marks and some technical marks to get. As long as the method is right, the knowledge is right, the practicing has been adequate. But if you cheat yourself on practicing and hope for a miracle, you will always be stunned by the challenging questions and be like, hey man, now, what did this thing just do to me? You will be startled, trust me. Hayi ke andifuna unothetha ngaba bathanda ukrema ke bona abantu abanqayayo. Hayi unqaya kusebenzi ke apha. Awunqayi nix, baqaya nje ufile ke. So ungafileyo nje ufuna ube ndikukhohlisa umntwana esikolo, so unganqayi, so zama nokuzama unqayi. Yes, iphepha soyalazi balivela kanjani. Sometimes I wonder why people always want to be told uba iphepha lime kanjani, and yet bayalazi. Hayi man, kaniyeni ukuthamba nina. You already know what the paper looks like. So why do you always choke on these things? Like you want to know what the paper should look like. I see a lot of people watching these silly things called predictions. I'm like, what the hell is wrong with these students though? They watch this thing religiously. You find that those videos called predictions, the students are watching in numbers, especially the night before the exam, and I'm like, these people are not serious though. Nothing is ever gonna be different. Question 1 is going to be algebra, with all the different variations and spices that can be put. Just be ready. Question 2 is always gonna be sequences and series. Okay? Question 3, if it is put again, it's gonna still be sequences and series, perhaps in a more technical way. But they will always be there. The same questions, you know, it's gonna be arithmetic sequence, geometric sequence, and series, then the quadratic stuff. It's always going to be those 3 types that you're going to have to handle. However, the examiner is going to structure the questions, but it's always going to be those topics. So folks, do you need to be told what to study, really? Aye, man, come on people, stop wasting your time on silly things like this. But I see a lot of you really wasting your time over just nonsensical commentary here. At least they should be teaching instead of telling you absolute garbage, because what does it help you with? That perhaps there's this. What is more important for me is those guys who actually do the predictions. You see, there are some good ones, obviously. Not everybody falls into the same category. There are some good ones where the prediction is just perhaps more like just a revision, which I don't know why they call it a prediction. Maybe to catch your eyes so that you can come and watch. But essentially, it's never really a prediction. It's more of a revision, which for me is good, because then they take you through some relevant questions and relevant topics to think about and concepts to really ensure you polish, which is good. So there are some good ones, but most are bad because they keep telling you what you already know, but you go and watch it anyway. And I'm like, what do you expect is going to be different? Yeah, toch, man. Save these kids. They're just dying out of, I don't understand. Misinformation, disinformation. Hey, don't take offense, Nina. Pekasa kango. Lilinyane msula. Ininyane ya kaka. Niti. Ya baba bana bese. Itseba hantle ntweng. Bane ga le batla utlwa nnete lona le batla maaka fela a monate bane ga kena ha monate ditsebeng tsa lona ka mona ebile le a hopola ntwena e maaka fela empa ha motho o jwetsa nnete ka baka la hore ntwena ha itle ha monate ha ikene ha monate ditsebeng ka mona bane e bua le wena hantle o tlo bontse o kwatile he jwale o sa batle o sheba le di videos tsa ka o sa batle lo di like hobaneng o sa batle nnete hobane nnete tla o thusa. Nnete ke setlhare ke moriana ntwena e tla o alafa wa bona. So tloela ntho tsena tsa ho bapala man tso senya nako mona o shebelletse ntho e tsebang hore ke yona ene tlo hlaka tsela ena ehlile fela ntho ke hore dipotso tsa teng di tlo ba thata hakaka ke yona fela ntho tshwanetseng hore o nahane ka yona hantle ntle o betere ha ile wena o nahana ka yona e se motho a o jwetse hore nahana ka yona hobane ke monahano wa hae seng wa hao and ha o fihla mane o tlo kopana le engwe ntho mane ganthe no fihla o tlo fihla nthong o ile ngwa inahana bo seng bo fitileng wa bona hlomo le wa inahana nthwena ka tsela ya hao and ha o inahanne ka tsela ya hao e tlo o thusa wana ha o kopana le diputso tseno o tlo tseba hantle hore o etse jwang empa ha o inahana ka tsela ya ka fela ha se ihlaile ntho ya teng e shebile kwana ha o no e bona hore ke pudi ntweng o tla re bona ntho e seonyana fela ka ke monotonyana ka mona ke tsebe ke moditse ntwena ke eng ha o tsebe bana ba tla bona manaka hore ke pudi ntweng ha isna manaka ntho ya teng ha o tsebe hore ke yona pudi yona ene ke shebile ya e tloshwa anyway guys, enough of my nonsense. I was just trying to pull your legs a bit and just push you around. I'm a bully anyway. See you guys next time. Goodbye.